Hey, Pokemon Math Professor back with you again today on looking at a brand new topic called slope. So, when we look at slope, there are actually three ways to find slope. Do you remember how to find slope in those three different ways? Well, here are the ways you can find slope. You can do it from a graph, you can do it from an equation, or you can do it if you are given any 2 points that are on the line you're trying to find the slope of. So let's look at the first one. What if we have a graph? So here's your steps for success. First thing you got to do is you need to find 2 points you can use to help you locate slope. Those 2 points, it's really convenient if they happen to be on the grid marks of the graph. It just makes it easier to do counting because we need to count what the rise is and what the run is. And we're going to use that rise and run to help us find the slope. So here we have an example. I have my line on my coordinate, and I'm looking for 2 spots where my line crosses grid lines. Now, I have some options here. Looks like -4, -2 could be a good option. -2, 1 could be a good option. And 0, 4 could also be a good option. Let's go ahead and choose -2, 1, and 4, 0, or 0, 4. I always like to choose points that are on one of the axes because then I always know one of the values is 0, and it tends to make things a little bit easier if we do that. Now, there are 2 different ways we can read rise and run. We can go from left to right. So start point on the left and go towards the point on the right. So I do the rise first. That means I count up. So as I count up, I go up 3, which is going to correspond to a number of +3 because the up direction is positive. Then I'm going to move 2 to the right. And when I choose a run, or when I count the run as being 2 to the right, that corresponds to a +2. So when I set up my slope as rise over run, I get +3 over +2. And since 2 doesn't go evenly into 3, I just leave it as a slope of 3/2. Now, I can also go right to left. In this case, I'm going to start with the dot on the right, that's at 0, 4, and go to the dot on the left. In this case, I have to go down 3. So my rise goes down, that gives me a value of -3. And when I do a run to the left of 2, that gives me a value of -2. So now my slope equation, rise over run, becomes -3 over -2, and a negative divided by a negative becomes positive, and I still end up with the exact same slope of 3/2. So it doesn't matter which points you go from left to right or right to left, as long as you make sure you're paying attention to those directions. Up and to the right are both positive, down and to the left are both negative. And if you follow those directions and our rules for dividing positives and negatives, you should have no problem coming up with the correct slope. Our second example looks at how we find it from an equation. Now, to be successful here, you need to solve the equation for y. Another way of describing it is putting it in slope-intercept form. Once it's in slope-intercept form, it's really easy to find the slope because then all you have to do is look for the coefficient of the x term. Let's look at an example. 5x minus 2y. I got to solve this for y. So I'm going to move the 5x term to the right side. I do that by subtracting. Now, to get the y by itself, I got to divide by -2. -5 divided by a -2 becomes a +5/2, and that +6 divided by -2 becomes -3. So now, I have it as y equals, or in slope-intercept form. Now it makes it very easy to find the slope is. I look for that coefficient of x, which is 5/2, so my slope is 5/2. Now the last way to find slope is given 2 points. Now, in this case, the steps for success, we're going to be using the slope formula, but I put one step before that. I take time to define my points and define my coordinates. I'm going to show you what I mean by define. That way, when I finally do set up the slope formula, I don't make mistakes. And then, of course, you simplify and you'll have your slope. So here's an example, -5, -4. And then the other point is 5, 1. The first thing I do is I label the points, point 1 and point 2. This is important because now I'm going to label the coordinates. The x-coordinate of point 1 becomes x1. Y-coordinate of point 1 is y1. X-coordinate of point 2 is x2. Y-coordinate of point 2 is y2. The reason I take time to do this is because here's the slope formula. It uses y2 minus y1 and x2 minus x1. If I don't actually know which numbers are which, there's a chance I could make mistakes. So I make sure to label before I plug into the formula. Next step, substitute. And now that I've labeled, I know I have my points in the correct order. 1 is y2, -4 is y1. Now, I put parentheses around the negative so that I don't confuse the subtraction as the negative. I have to subtract a -4. And then in the denominator, 5 minus -5, I have to subtract that -5. Now, remember, minus a negative number or a negative, two negatives make a positive, so 1 minus -4 is the same as 1 plus 4, or 5, and 5 minus -5 is the same as 5 plus 5, which makes 10. And now that I have it as 5 over 10, I'm not really done. Whenever I have a fraction, especially with slopes, we really want to simplify into the smallest value possible. So 5 over 10, that simplifies to 1/2, and I have my slope. And that's how you find slope given 2 points. Now, slope is essential for linear functions, okay? All linear functions can be written in slope-intercept form. It's helpful if you're trying to graph lines or if you're trying to look for things like parallel or perpendicular. So knowing how to find a slope in any of these three situations can be really helpful in any sort of problems related to, graphing or parallel or perpendicular. As always, thank you to SlidesGo for helping me out with my presentation.